Hello friends, welcome to the new session. Today's session we are going to see about moments and moment generating function. Previously we know that the expectation E of x, or people say it as mean. Do you remember? The formula for expectation E of x, we say it as mu, and then similarly we found E of x square. Then from E of x and E of x square we found the variance V of x. We know the relation between E of x and E of x square will give the variance. So E of x is simply my mean, and then my variance is going to be E of x square minus E of x whole square. Now we are going to see what is meant by moments. Okay, let us see. The expected value what we are calculated is called mean. Now we say the expected value of an integral power. The expected value of an integral power of a random variable is called a moment. Okay, now I can say raw moments. What is raw moments? Or people say it as moment about the origin. Moment about the origin. So what is the rth moment about the origin? We give the notation mu r dash is nothing but e of x power r. Okay, so this is called the rth moment of a random variable about the origin. So now when we put r equal to 1, we will get the classical E of x, that is the mean. When you put r equal to 2, we will be getting E of x square. Mu equal to 3, we will be getting E of x cube, etc., etc. So now let us go into the next one. So what we see is raw moments, or moment about the point origin. Next we are going to see about central moment. Next we are going to see about central moments. Central moment, or it is alternatively called as moment about the mean. What is the mean? Do you remember? The mean is x equal to mu. Mu is my mean. Okay, so when I'm going to find the moments about the mean, or I can say it is a central moment, now I will use the formula, I will use the notation mu r. If it is moment about the origin, I'll use mu r dash. If it is moment about the mean, I will use the notation mu r. So I think you would have guessed the formula. So it is going to be x minus mu whole power r. Okay, done, guys. So if my mu is equal to 0, then it will become what? My moment about the origin. Now the third concept, what we have, the other one, moment about a particular point A. So moment about a particular point, let us say x equal to A. Now you would have guessed the formula very easily. What it is? Yes, mu r dash, that is going to be E of x minus A whole power r. Now you would have get the concept. So when my point A equal to 0, when my point A equal to 0, my moment about the point x equal to A will become what? Simply it become a raw moment. I'll say it as E of x power r. Is it clear? So we seen three types of moment. What it is? The first one is moment about the origin, that is x equal to 0 we think, and the second one is moment about a particular point A, and we see the formula is this, and the final one is moment about the mean mu equal to, so we take E of x minus mu whole power r. So these are all the three moments we are dealing in this topic. And very important point I'm going to say now, whenever I speak the word simply moments, it always refer to what? Moment about the origin. You should not think that if I say moment means it is not at a particular point, or it is not a central moment, or it is not about the mean. If I say simply moments, it always refers my classical moment about the point origin, or I will say it as raw moments. Is it clear? So with this data, I am going to give explanation about the relation between moments, that is central moments, and the raw moments. So this is very important for our MCQ as well as part B questions. Let's go. So now mu r, we know that E of x minus mu whole power r. So let me put 1, r is equal to 1, E of x minus E of mu. So we know the formula expectation. If you don't know what is the formula for expectation, kindly go and refer the discrete random variable videos and come back. And the link is given in the description. You can see and you can click and come back here. So we know that expectation of constant is always constant. So E of mu is going to be what? Mu. E of x, already know it is nothing but what? The classical mean, mu. So from this what we get, my mu1 is always 0. So my first central moment is always 0. It's a very important MCQ. If somebody was interested to see the proof of mu2, mu3, etc., what I am going to give now as a formula, you can check the handwritten material or the reference material which I provide. So now we know that mu1 is 0. That is my formula. Now my second formula, mu2. My mu2 is nothing but mu2 dash minus mu1 dash whole square. Okay, done. Similarly, in your exams, they will ask up to mu4. Now my mu4 is nothing but, mu3 is nothing but mu3 dash minus 3 times mu2 dash mu1 dash plus 2 times mu1 dash whole cube. Done. Similarly, finally, we will write what? Mu4. So you have to remember, I don't say memorize, you have to remember this formula in the exam point of view in your own way. Mu1 dash plus 6 times mu2 dash mu1 dash whole square minus mu1 dash whole power 4. Okay, here also there is one. Yeah, I'll rewrite this. Minus mu1 dash whole power 4. Now you can find some similarity. Here mu1 dash 2 times, 3 times. So something like this you connect by yourself and remember the formula in an easy way to write in the exam. So now this mu1, mu2, mu3 has a lot of applications. We already discussed all those things in our class. Like what mu2 is my classical variance, and we already speak that what is my mu3 and mu4 are used for, like we speak about the skewness, like how mu3 is helpful to find the skewness and how mu4 is helpful in kurtosis. All these things, the application part we have discussed in the class. Let us go to the problem part. Okay guys, so now let's go into a problem. So they can give some data and we have to find mu1, mu2, mu3, mu4, etc. So they say the words, the first four moments of a distribution about x equal to 4 or 1, 4, 10 and 45 show that my mean is 5, variance is 3, mu3 is 0 and finally mu4 is 26. So this is what I have to show. So you have to understand the question. First of all, what is asked to you. So now listen, I want to give one more relation. So mu r dash is e of x minus a whole power r. When you put mu1 dash, it will become what? E of x minus a. I am writing directly. Okay. So mu1 dash plus a will give you mu. So this is the another formula for mu. Okay. If you want to find mu, if you know the mu1 dash and the particular point a, if you add it, you will be getting the mean. This is the another formula. Okay, let's go into the problem, guys. So first of all, we have to understand what is the question. The first four moments. So is it raw moment, or it is a central moment, or it is a moment about a point? Now you see the first four moments about x equal to 4. So that means it is moment about a particular point x equal to a. So here in my question it is given x equal to 4. Therefore my point a is equal to 4. Done. So the first four moments about the point means it is going to be obviously mu1 dash, mu2 dash, mu3 dash and mu4 dash, guys. It's going to be 1, 4, 10 and 45. Now you see, I want to find what? I want to prove the mean is 5. Now it's going to be very simple and obvious. Why? Because I know this formula. Mean is equal to mu1 dash plus a. So my mean is going to be mu1 dash value is 1 and then my a is going to be 4. So 4 plus 1 is 5. Hence I proved the mean is 5. Now I have to go for what? The classical variance. So my mu2 is my variance. You know, mu2 dash minus mu1 dash whole square. So now just substitute the value. Just substitute the value of mu2 dash and mu1 dash here. So my mu2 dash is 4, mu1 dash is 1 square. So 4 minus 1 is 3. So I proved my variance is 3. I proved my mean is 5. Now similarly what you have to do? you have to prove mu3 and mu4. So now you go to the formula, see here. Okay, I'll take this. Yeah, okay. Now you can see this formula just now we see. Now you substitute the value here. You substitute the value of mu3. So it's going to be 10. Now 3 into 4 into 1 and 2 into this is 1. So when you add 10 minus 12 plus 2, it is going to be 0. Done. When you come here, mu4 dash 45 minus 4 into 10 into 1 plus 6 into 4 into 1. You can see the question 3 into 1. So when you expand this, you will be getting 26. So I proved all the values mu1, mu2, mu3, mu4, etc. Done. So these kind of problems people can ask given a relation of moment about a particular point A, and they will tell you to find the central moments mu2, mu3, mu4, etc. Okay, they will not ask you to find mu1 because mu1 is 0. Hope you understand. So they can ask any kind of problems like this. Okay, in the case of MCQs, they can ask very simple. They will not go for mu3, mu4. They will be asking simple problems like this. Okay, you will take simply the first two moments. The first two moments about the three are 1 and 8. You have to understand the question. That's it. Find mean and variance. Simple. Find mean and variance. So now you have to rate the question. First two moments about 3. That means about the point x equal to a. So that means the information given on mu1 dash, mu2 dash. Mu1 dash is 1, mu2 dash is 8. So I said mu is mu1 dash plus a. Immediately I can write. So what is my answer? Mu1 dash is 1. A is going to be 3 here according to this problem. So my mean is going to be simply what? My mean is going to be 3 plus 1, that is 4. This is done. So next what I have to find? Next I have to find my variance. So my variance of x is mu2 dash minus mu1 dash whole square. Mu2 dash is 8, mu1 dash is 1 square, 8 minus 1, 7. So these kind of problems you can expect for your MCQ guys. So it is going to be very simple. So now again what I will do, I will give a clear idea. So what we say, we take the moments are what? The moments are classified into two things. One is central moment. So just content in a nutshell. So central moment, or we say moment about the mean. So whenever I said moment about the mean, I am going to take x equal to mu. Similarly, the other hand, it's called raw moments. Okay. Yeah, I'll write clearly. Raw moments. So what is the other name of raw moments? Moment about origin. Okay. So we'll take the point as x equal to 0 here. Okay. So the central moments, I am going to give the notation mu r. The raw moments, I am going to give the notation mu r dash. So it is nothing but expectation of x minus mu whole power r. Here simply expectation of x power r, because here mu, here it is 0. So now the same thing we can say, we can extend this. Okay, moment about a particular point, moment about here, moment about a particular point. Let us say, what is the point? X equal to a. In this case also we'll be getting what? The same mu r dash, and we express this as x minus a whole power r, guys. And the final point, as it is, as usual, I say, whenever I say simply the word moments, it always represents what? The raw moments. So here we stop the video. We give a clear idea about moments and relationship between central moments with the moment about a particular point, and we give the formula mu1, mu2, mu3, mu4, how to find from mu1 dash, mu2 dash, mu3 dash, mu4 dash. Okay, so in the next video we are going to deal with moment generating functions, and from the moment generating functions, how we are going to find the mean and variance. Yeah, thanks for watching and thanks for your big support, guys. See you in the next video. Bye bye.